Hey Geometry 2 students, Ms. Craft here. Today we're going to be going over 11.3 notes, which is corresponding parts of similar figures. We have no new vocab, so we're going to jump right into the lesson. Properties of similar figures is our first example, and I've left the first one blank for you because it's a combination of the next two. Okay, so I've done the next two for you, and if you would like, I would recommend identifying your proportional sides and congruent angles. Okay, so in the second example, triangle RST is similar to triangle XYZ. Your one little tilde is how you notate similarity. And we're going to write proportionality statements for the corresponding sides of the figure. Okay, what this means is segment TR is going to be similar to segment ZX, segment RS is going to be similar to segment XY, and segment ST is going to be similar to segment YZ. You have the values on here, but we're not to values yet, so all we need to do is write our proportionality statement. And your proportionality statement is literally just identifying your corresponding segments and noting that the ratios have to be congruent. These segments are not congruent, that's why I put this here. The segments are similar, okay? When the segments are similar, it means that their ratios are congruent. So segment RS over segment XY, so the ratio of RS to XY, has to be equal to the ratio of ST to YZ, which has to be equal to the ratio of segment TR to segment ZX. Okay, so that's how you write the proportionality statements for your segments. You're just identifying which segments correspond to which, and then setting each of those ratios equal to each other. Okay, this is not my proportionality statement. I just wanted you to understand that segments are similar, they are not congruent. So in the last example here, polygon map is similar to polygon dog, super creative. And we're going to identify which angles in the figure have to be congruent. I tried to make this very clear that angles are congruent, hence it's bolded in your first example, and segments or sides are proportional. So here I drew these out and I marked my notations so that you would see what I mean by that, I guess. So polygon MAP and polygon DOG. Again, the naming sequence tells me what corresponds to what. So I know that in my figure, angle M is congruent to angle D. So I wrote that here. Angle A congruent to angle O, and then angle P congruent to angle G. All of my corresponding parts map to each other. Okay, so again, if you wanted to complete example 1, I would recommend that, but that's how you write your proportionality statements or your congruence statements for angles. All right, applying properties of similar figures. First of all, I did not realize how small I made these boxes for what I was asking until obviously I attempted to do them myself, so I apologize. What I do want to make very clear is that I use tons of fractions because fractions are awesome. Fractions are numbers too, and we love fractions. I hate decimals, so unless you are told to use decimals, please leave everything as an improper fraction. On my quizzes and exams, I tried to make sure that you know what is expected if it's a decimal or a fraction. If it does not say, please leave it as an improper fraction. Do not turn things into mixed numbers and leave them. Just leave them as is. It actually makes the work a lot easier for you. Okay, so the first example in applying properties of similar figures, it is your job to identify basically what segments correspond to what segments in your other figure. You have corresponding congruent angle marks, so that's how I tried to match these. What I then look for is my longest sides, my shortest sides, whatever, something that's identifiable to identify what segments correspond to the other segment in the other triangle. So this one here, I know that 27 corresponds to Y. I know that the side that's 24 corresponds to the side that's 18, and then 39 corresponds to X minus 6. All of these ratios have to be equal in order for the triangles to be similar, and because I already know they're similar, I know that they're equal. Okay, so we're solving for X and Y. So I just took these middle two, the last two, because you have to have one ratio that's completely numbers. Unless your ratio is using the same variable, but I have two variables here, I can't try to solve with 27 over Y and 39 over X minus 6, because that's two variables that I'm solving for and only two equations, and that's not enough. Okay, so look for a fraction that has all numbers and then find how that corresponds to what you're solving for. So 24 over 18 equals to 39 over x minus 6. The first thing that I did here was reduce 24 and 18 because obviously it's a lot easier to work with smaller numbers, so I get 4 over 3. I am a stickler about how you use fractions. A fraction bar is just division. The inverse of division is multiplication. So to undo division, I'm going to multiply by what's being divided. On the right side, it's being divided by x minus 6, so I'm going to multiply by x minus 6 on both sides to undo that. And that cancels out the fraction on the right, so I'm left with just 39. And then on the left side, I'm doing 4 times x and 4 times negative 6. Okay, this is over 1, so the 3 stays the same. That's why the 3 is still here. So I get 4x minus 24 over 3 equal to 39. Then I still have a fraction on the left side. You cannot technically do real math with fractions, so that's why we eliminate them. So again, a fraction bar is division. The inverse of division is multiplication. So I'm going to multiply each side by what's being divided. So I multiply the left side by 3 and the right side by 3. This cancels out my fraction, so I'm left with 4x minus 24, and then 39 times 3 is 117. Okay, then I do not show my basic algebraic steps because at this point you should be pretty fluent in algebra, but we do use lots of algebra and geometry, so if you need extra help, please come to tutoring or ask me to do a Canvas conference with you, and I'd be more than happy to help you out. I'm going to add 24 to each side, I get 141, and then I divide each side by 4, and I get x equals 141 over 4. Perfect, leave it as an improper fraction, that's my answer. Y was a little bit easier to solve for because it's just one term. So I took the first two from my original proportionality statement. 27 over y equals 24 over 18. I did the same thing, I reduced 24 and 18 first to get 4 over 3. And then I chose to get rid of my variable in the denominator. So again, fraction bar is division. The inverse of division is multiplication, so I multiplied both sides by y. This is technically multiplying by y over 1. So I get 4y over 3. And then 27 is what's left on the left side. Then I have another fraction, so I multiply by its denominator, multiplied both sides by 3, and I get 81 equals 4y. Then I'm going to divide each side by 4y, and I get y equals 81 over 4. Again, perfect, looks good. That's my answer. This next example is tons of work, and again, I apologize. I didn't realize how much I was asking and putting it in this small box. However, finding the ratio of perimeters and areas is something that AZ Merit really likes to do because similarity is easy. Identifying similarity in regards to perimeter and area is a little bit tougher. So it's a higher level question here. Okay, so what I did was I identified all of my corresponding sides. I assigned this missing side variable z because we need it in order to find the perimeter. If you were just asked to solve for x and y, oh no, z is already there and I forgot to solve for that angle. That's 65 degrees, so I apologize. When I solve for z, I'm solving for my variable because I just want to know area and perimeter. Okay, so again, I apologize for that. So this is y over 30 equal to 11 over x equal to 8 over 20 equal to 3 over z. I know that I have to use 8 over 20 because it's my only fraction without a variable in it, so that's going to be used each time that I solve for my missing sides. Okay, I solved for y first just because it was the first one that I wrote in my ratio. So y over 30 equal to 8 over 20. Again, first I reduced and then I solved. I'm not going to walk through step by step me solving. I just did that for you in the first example. So again, if you have questions, message me in Canvas. But basically, I just want to get to my answers. Y is 12, x is 55 over 2, and z is 15 over 2. Okay, using the same proportion for each one. Then, I have to do perimeter. Okay, so the ratio of each perimeter. Perimeter is just adding all of your sides together. So I have 12, 3, 11, and 8. That's what I found for quadrilateral EFGH. Okay, and that gave me a perimeter of 34. The other perimeter, I have 20, 30, 55 over 2, and 15 over 2. I was able to combine 55 over 2 and 15 over 2. That gave me 70 over 2, and 70 divided by 2 is 35. So I had 20 plus 30 plus 35. That's how I got 85 here. And then in order to find the ratio, I just did 85 divided by 34. That's how I got 2.5. So the perimeter is 2.5 times greater. Okay, then we have to find area. Area of a trapezoid. Again, quadrilaterals are in Geometry 1, so if you don't remember, Google is a great resource, I guess. So the area is 1/2 b sub 1 plus b sub 2 times the height. B sub 1 and b sub 2 are just your parallel sides, and it doesn't matter which one goes first. So I have, for my first quadrilateral, EFGH, 1/2 of 8 plus 3 times 11. Because these are right angles, it gives me my height, so I didn't have to solve for anything. Okay, so that's 1/2 of 11 times 11, which gives me 121 over 2. Finding the area of JKLM was a little messier because I have two fractions. My height is 55 over 2. My x value is my height based on the right angles. So I have 1/2 times 20 plus 15 over 2, and then I'm multiplying that by the height of 55 over 2. So what I did was multiplied 1/2 and 55 over 2. That's where I got this 55 over 4. And then I added 20 and 15 over 2. The way that I did that is I made 20 over 2, and that's multiplying 20 over 1 times 2 over 2. So I got 40 over 2. And then I did 40 plus 15 over 2, which is how I got 55 over 2. You then have to multiply straight across. So I got 55 times 55 is 3,025 over 8. Okay, I did the same thing here. I just divided 3,025 over 8, divided by 121 over 2. And up at the top here is where I fit it in. So again, I apologize. The area is 6.25 times greater between the two figures. Okay, super easy way to check this. Area is a squared unit of measurement. And again, we will do this later in the semester, so it's kind of a nice preview for you. 2.5 squared is 6.25. So your area should always be the squared value of your perimeter ratio. Okay, I left a couple blank for you here if you wanted to practice. And then we move on to a couple more examples. In this diagram, a triangle ACD is similar to triangle ABE, and I asked you to find the values of x and y. When I created this figure, I did not create enough information for you to solve for y. So if you notice, you don't have that here. It's just important for you to know that angles are congruent and segments are proportional. And I wrote this statement before I realized that you can't solve for y. So again, I apologize, but this one is just solving for x. I did x plus 2 over 10. That has to be equal to x minus 1 over 6.25. So I simplified all of this, the same algebra that I did above, and I get x equals 6. Okay, in this case, if you were to get an answer that did not reduce nicely, because decimals are how your question starts, decimals would be how your question ends, but this one does go in evenly. Okay, my next example is just identifying what a transformation does. So this becomes irrelevant. If triangle TUV maps to MLK and I have a translation, that doesn't change anything about my size. But then I have a dilation of 4 times my x and y values. So if segment TU is 3 and it got multiplied by 4, then segment ML would be its length times, oh my gosh, the dilation, which I wrote 3, and I'm sorry, it should have been 4, so that's going to be 12. So if you're taking notes, please change that to 12. Okay. On this one here, just make sure you're paying attention to the way that I wrote it. QR is 7 here, and if this is a dilation of 1/3, then you're going to have to work backwards. So if 1/3 got me 7, then 7 times 3 will give me that length. Last example is very much like the one above it. The pair of polygons is similar. We're going to find the lengths of AC and EC. I have fractions here, so I just wanted you to see basically how I operate with fractions. When I solved, I got x equals 3/5, and then I plugged in each one. AC is 38/5, and EC is 57/5, and again, I left those as improper fractions. So that's all I have for you for this lesson. If you have any questions, again, please send me a Canvas message. Thanks.